Now let's look at figure 15-7B from Stallcup's Electrical Design book, volume 2. And we just previously used the resistivity of the wire to calculate the voltage drop. Now we're going to use the circular mill rating to do so. I don't believe it makes that big a difference, but designers and installers said the resistivity method was more accurate. Now, for example, using the circular mill method to determine the voltage drop and size element of a single-phase feeder having the following characteristics. So voltage drop 3%, voltage is 240, the length is 300, the load is 180, the overcurrent device is 200 amps, and we have a 3-aught again. Now, all we're doing, we're using the same characteristics to determine what size conductor we would need based upon circular mill rating of the wire and not the resistivity of the wire. So let's look at it. Step 1, we're applying 215.2A1 informational note again, holding the feeder to 3%. So we go into step 2 and we take voltage drop, 2 times R times L times I, but we're dividing by the circular mill. Not 1,000, but we're dividing by the circular mill. So voltage drop is 2 times 12.9 now for this copper. If it was anything else, we'd have a different, but 12.9 times 300 times 180, divide by 167,800, which is a circular mill rating of that 3-aught. Voltage drop then is 8.3027. You can see it really doesn't make any difference, really, which method. And then the voltage drop supply, we're still wanting to hold to 3%, so 240 at 3%. 7.2 is what we're holding. So applying again the 215.2A1 informational note 2, voltage drop divided by 240. So the voltage drop in step 2 was 8.3027. Divide that by 240, we come up with 0.0345 or 3.45. So it appears here we're just a little bit high here. We're 3.45 and we're wanting to hold to 3%. So we'll try the 4-aught over here next and see if that's going to do the trick. So we're still step 1 holding to 3%. Step 2, then we take the voltage drop times 2 times R times L times amps, 211,600. We divide by that the circular mill rating of a 3-aught conductor from Table 8, Chapter 9. And when we do our math, again, see, we'd have 2 times 12.9 times 300 times 180, divide by 211,600. We'd come up with a percent of 6.584 divided by 240 in step 3. And notice here we come up now with 0.0274, which is 2.74. So we are below the 3%. So the 4-aught did the same job for us that the resistivity method did when using the circular mill rating. And the circular mill rating was used for years until they brought up the resistivity method. So to me, it really doesn't make that big a difference, but use the resistivity method if you want to kind of be in line with what the inspectors like to see you use. But again, remember, an informational note is not a mandatory requirement. It is a suggestion that if you hold 5% overall for a feeder or branch circuit, however you're running your calculation, your equipment should operate okay and not have a voltage drop problem, and that's what your figure 15-7B is illustrating.